Bismillahirrahmanirrahim. Assalamu alaikum, my dear viewers. My name is Noor Asif and I am from the Department of BS Mathematics. Today, the topic of my presentation is hydrofluoric acid. Now, the first we will have a look at the content table about what we will discuss about hydrofluoric acid. We will discuss the introduction, history and discovery, chemical composition, its geometry and structure, the properties of hydrofluoric acid, how it is prepared and manufactured in the laboratories and industries, what are its chemical properties, health hazards, and how to avoid those health hazards and its uses. Now, first, let's start to the introduction of hydrofluoric acid. Hydrogen fluoride or hydrofluoric acid, when dissolved in water, is one of the nastiest but also most useful compound known to chemistry. Hydrofluoric acid is related to the most commonly hydrochloric acid found in our stomach. It is used to make most fluorine-containing compounds. Examples include the commonly used pharmaceutical antidepressants. Elemental fluorine is produced from it. It is commonly used to etch glass and silicon wafers. Now, what is etching? It is used in the microfabrication to chemically remove the layer from the surface of wafers during manufacturing. Solution of hydrogen fluorides are colorless, acidic, and highly corrosive. When hydrofluoric acid comes in contact with the human skin, it causes deep burns. Now, this is the picture of hydrofluoric acid. How, as you can see, it is a colorless liquid in a plastic bottle. It is put in a plastic bottle because it readily reacts with glass. Now, what is the history of hydrofluoric acid? Swedish pharmaceutical chemist Carl William Scheele discovered hydrofluoric acid in 1971. How he discovered it? When he investigated the composition of a mineral called fluorspar. What is fluorspar? Fluorspar is the mineral form of calcium fluoride at a time when the element fluorine was unknown. All the acids were thought to contain oxygen. Carl noticed the glass etching properties of the fumes that develop when heating fluorspar and sulfuric acid. Uh, uh, Now, what happened was when Carl was heating fluorspar and sulfuric acid, he noticed some fumes that were reacting with glass. So, leading fumes into water, he was the first to make large quantities of hydrofluoric acid. When he dissolved those fumes into water, hydrofluoric acid was produced. The exposure to hydrofluoric acid, along with Carl's bad habit of tasting and smelling the substances he discovered, might have been one of the causes for his death at the age of just 43. As you can see, this can be a fatal compound. By only tasting and smelling this substance, he would have been died. Now, this is the picture of Carl William Scheele. He was a Swedish-German pharmaceutical chemist. He discovered oxygen, identified many elements, for example, tungsten, barium, hydrogen, and chlorine, among others. He also discovered many type of acids. Acids such as organic acid, tartaric acid, oxalic acid, uric acid, lactic acid, citric acid, also hydrofluoric and arsenic acid. Now, what is the chemical composition of hydrofluoric acid? The formula for hydrofluoric acid is given as HF. The acid consists of diatomic molecule with strong intermolecular hydrogen bonds. Now, diatomic molecules means the molecules that only compose of two atoms. But these atoms may be same or of different elements. It consists of a single covalent bond. The chains in the molecules are usually shorter. Now, this is the geometry of hydrogen fluoride. It is also called as ball and stick model of hydrogen fluoride. Now, this is the Lewis dot structure of hydrogen fluoride. The atomic number of hydrogen is 1 and fluoride is 9. Fluorine has 9. 9 is its atomic number and has 7 electrons in its outermost shell, valence shell. So these seven atoms and this one atom, seven electrons and one electron make the bonds, single covalent bond, and fluorine completes its octet rule, and hydrogen completes its duplet rule. Now let's discuss the properties of hydrogen fluoride. As I said before, its formula is given as HF. Its molar mass is 20.006 gram per moles. It is a colorless liquid below 20 degrees Celsius. Now, about density, melting point, and boiling point depends upon the concentration, about how much concentrated the solution is, but mainly its density is 1.15 gram per milliliter. Its melting point is minus 83.6 degrees Celsius. It has a very low melting point that I don't know if I can achieve in our daily life or not. Its boiling point is 19.5 degrees Celsius. Now, how it is prepared in laboratories. The industrial preparation of hydrofluoric acid involves the reaction of chloride with concentrated sulfuric acid at high temperature of 265 degrees Celsius. This reaction produces hydrogen chloride and calcium sulfate. Now, as you can see in this reaction, that calcium fluoride and concentrated sulfuric acid are heated at a very high temperature. Now, its byproducts are 2 moles of hydrogen fluoride gas and solid calcium sulfate. The hydrogen fluoride gas is dissolved in water to prepare hydrofluoric acid in different concentrations. Now, this hydrogen fluoride gas is dissolved in water to make different concentrations of hydrofluoric acid. It means that the concentration of hydrofluoric acid depends on how much water it is dissolved in. The gas is dissolved in. If the gas is dissolved in less water, it is more concentrated, and if the gas is dissolved in more water, it is more concentrated, less concentrated. Now, how it is manufactured in industries. Anhydrous hydrogen fluoride. It means that crystallized form of hydrogen fluoride. It contains no water. And hydrofluoric acid in aqueous form are the basis for the variety of fluorocarbon compounds such as solvents, sources of raw materials for the production of anesthetics, and fire extinguishing agents. Hydrofluoric acid is manufactured by heating acid-grade fluorspar with sulfuric acid. As I said before, fluorspar is and sulfuric acid are heated at a very high temperature. Now, what does acid grade mean? Acid grade means the purest form, highly pure. It is about 99% of calcium fluoride. Fluorspar means mineral form of calcium fluoride. It is formed by gaseous hydrogen fluoride, and forms calcium hydrogen fluoride and solid calcium sulfate as byproduct. The endothermic reaction takes place in a rotatory furnace. It is an endothermic reaction. It means that it absorbs heat from its surrounding, and it takes place in the rotatory tube. Furnace is also a heating device. This entire process is kept in the vacuum to help full of the product gases and to promote hydrogen fluoride production. The technique of heating the rotatory furnace by the means of general combustion chamber is the usual practice today. Some techniques report the energy management and the conversion controlled by 3 up to 15 chambers with a temperature gradient of usually 300 to 400 degrees Celsius. Now, this process involves only 4 stages. Fluorspar drying, reaction of fluorspar with sulfuric acid, hydrofluoric acid purification and scrubbing to make high-grade hydrofluoric acid that is 99.9898% pure. The crude liquid hydrogen fluoride is boiled and distilled. Now let's see what is happening here. As you can see, the dry fluorspar and sulfuric acid are mixed and heated in a rotatory kiln that has endothermic reaction. This rotatory kiln is kept into vacuum and it produces anhydride solid calcium sulfate, and hydrogen fluoride gas. It is then hydrogen fluoride gas is goes into washing column where it is scrubbed and cleaned. Then it is put into the condenser. It is put where it cools down, and then again it goes through the distillation process where 99.98% of the hydrogen fluoride, pure hydrogen fluoride, is obtained uh, in the form without water, crystallized form. And then water molecules are added, and a hydrofluoric acid in its aqueous solution is obtained. Now, what are the chemical properties of hydrofluoric acid? Hydrofluoric acid is a very strong reactive and corrosive acid. It is one of the most reactive elements. It readily reacts with bases and acids and oxidants. One of the best reaction is its corrosive dissolving effect on glass and ceramics. It is highly damaging. Hydrogen fluoride is a highly damaging acid. It readily reacts with glass and ceramics. Due to its reactivity towards glass and metals, it is typically stored in plastic containers. I told you before when I showed you the picture of the uh, this liquid. Now, what are the health hazards and safety? Hydrofluoric acid is highly corrosive liquid and contact with skin which causes severe poisoning through skin contact and inhalation and ingestion. To avoid this, we should wear gloves, safety glasses and masks. We should also wear our lab coats and work with it with concentration so we can avoid this. HF rapidly penetrates the tissues and can permanently damage eyes, lungs, and mucus. If there is any contact with it, you should immediately call for medical help or what your emergency numbers are. Upon skin contact, the concentrated acid also causes severe burns and can even lead to cardiac arrest and fatality. Now, as you can see here, it is highly fatal. This acid can also cause death. Even mild exposure to HF, in mild exposure to HF can cause symptoms such as irritation, irritation of eyes and throat, the eye and skin burns, pulmonary edema, and skin and bone damage. Strong acid concentration cause severe immediate burning pain, and whitish discoloration of the skin, which usually proceeds to blister formation. In opposite, the effect of more dilute solution may be delayed. Latency period symptoms, the when uh, the latency period of symptoms, it means that after how much time the symptoms are shown. The symptoms are mainly redness, swelling, and blisters to appear after the exposure of HF solution in 20 to 50 concentration range, maybe up to 8 hours. And the concentration of less than 20% may not produce symptoms for more than for up to 24 hours. Acid on skin. Now I will tell here how does the acid reacts on skin. HF can penetrate skin because it is miscible with both water and fat. The HF bond is so strong that the molecules stay intact until it reaches deep tissue. There it dissociates, producing hydrogen ions, also known as acid, and highly reactive free fluorine ions. These fluorine ions create havoc on tissues, turning them into viscous substance. They also bind with calcium ions and other positively charged ions. That causes our nerves to release potassium ions, which you feel as horrible pain. Now, what is happening here? As you can see that here HF is penetrating, hydrofluoric acid is penetrating through skin as it is miscible with fat and water. Now, what is our skin? It is basically fat. Now, here the molecules of hydrogen and fluoride are gone deep into tissues. It will not form ions until because will not form ions until it is deep in tissues, because it is a very strong bond. It has a very strong bond. As you can see, it has made ions, fluorine negative ions and hydrogen positive ions. Now, fluorine negative ions are damaging tissues. As I said, it creates havoc in the tissues, and this reacts, and the fluorine ions react with calcium, positive calcium and ions and other positive ions, and and other positive ions, uh, that causes our nerves to produce potassium. And the release of potassium is very painful to our skin. Now, what are the uses? And in industrial setting, with proper equipment and safety precautions in place, it can be used. Hydrogen fluoride is extremely useful. It is the key ingredient for imparting fluorine atoms into organic molecules, making things like Teflon, refrigerants, and pharmaceuticals. And because it can dissolve gas, it can dissolve glass. It is used to etch the patterns on silicon wafers, uh, turning them into chips inside the electronic device below. It is also used to make the electronic chips. As I said, for it has glass etching properties, and that, so despite its dangers, without hydrogen fluoride, we would not have much for our modern tech. Now, as nasty as hydrogen fluoride might sound, but a world without hydrofluoric acid would be pretty miserable. Now, thank you, and that's all for my presentation.